talk about polynomial functions again. Yay! Okay, so polynomial expressions are basically the types of functions that we've been dealing with here, where you've got variables that have exponents, and the exponents are basically integers, right? That are positive or zero, right? So like a to the 1, a to the 2, a to the 3. You never have like a to the half or root a or whatever, right? Now, we say a polynomial is in standard form when the degrees are written in descending order. So for example, if I have f of x is equal to negative x squared plus x to the 4 plus x, this is not in standard form. These are out of order, okay? So not in standard form. However, to put it in standard form, I just rearrange them so that x to the 4 comes first, right? So first it's the highest exponent, then negative x squared, then plus x. This is in standard form. Okay? Okay. So the coefficient of the term with the largest degree is called the leading coefficient. The degree of the polynomial is the greatest degree of its terms. Okay, so take a look at this one. First of all, is this in standard form? Yes. Okay. What is the degree? Yep. 6. It's the highest exponent. That's the degree. Okay? The leading coefficient is the coefficient of that term. So the leading degree was the 6. The 5 is the leading coefficient. Okay? All right. So these, let's take out your calculator because we're going to do this with the help of your calculator. I just want to make sure you all know exactly like how to execute this so you get the whole correct answer afterwards, right? Okay, so I want f of 2. That means I have to put 2 in the place of every single x. So I have negative 2 times 2 squared minus 3 times 2 plus 4. Okay? Hang on. We're going to put this in the calculator exactly the way it is. And I'm going to do it with you. So take a look. Here. Okay, so look. Negative 2 in parentheses 2 squared okay. What else do we have? Minus 3 times 2 plus 4. You get negative 10. Okay? So many times when I am grading your tests, your quizzes, your final, this is written out correctly, but then the negatives aren't executed in the calculation properly, so you end up getting an incorrect answer, right? So I really want to minimize that this semester, okay? Do you have a question? No. Okay. So next, 3 times f of a. So now this is 3 times f of a. For this one, we have to kind of split this up. This is 3 times. Now, what is f of a? F of a is when you put a instead of all of the x's. So in parentheses, we're going to do negative 2a squared minus 3a plus 4. Next, I'm going to distribute the 3. Negative 6a squared, negative 9a plus 12. Okay? So this had two components, 3 times f of a. I did f of a first and then multiplied by the 3. Okay? Now, next I have p of 3a. That means for each of the x's here, I'm going to put in 3a. We divide and conquer here. So this is equal to 3 times 3a squared. Come on. Plus 2 times 3a minus 5. Okay, now here. Am I going to multiply by the purple 3 first, or am I going to square first? Square first. Okay, who does that square belong to? The red a, the red 3, or both? Both. Okay, so this is going to be 3 times 9a squared, right? Square, square. Plus, how much is this? 6a minus 5. Here, how much is this? 27a squared. Yeah. Okay? Yeah.
I thought when you multiply, it's just to add the exponents. Like, would it be like 3a to the first power plus, and like, you know what I'm saying? Like, why wouldn't it be 9a cubed?
Because, okay, so 3 squared is 9. And then a squared is just a squared.
Okay.
Yeah.
But what is it when you multiply?
When you had a times a, like you would add.
I see.
Yeah. Okay, so here now I have p of 2a squared. So now I'm going to put in 2a squared for each of the highlighted x's. So this is going to be 3 times 2a squared squared plus 2 times, how much? 2a squared plus 5. Oh, minus 5, thank you. Okay, so now look, this belongs to both of them, right? Okay, so I have 3 times 2 squared is 4. A squared squared is a to the 4. Multiply. Plus 4a squared minus 5. So I have 12a to the 4 plus 4a squared minus 5.
How do you get 12?
3 times 4 is 12. Okay, so next. We have 5 times p of 2a. So this is going to be 5 times, and let's see what p of 2a is. Now I'm going to put 2a for each of them. So I get 3 times 2a squared plus 2 times 2a minus 5. So this is 5 times, in parentheses, let's see what we have. 3 times, I distribute this. 2 squared gives me 4a to the power of 2a squared. Plus 4a minus 5. So this is 5 times 3 times 4, 12a squared plus 4a minus 5. Distribute all the 5s. 5 times 12, 60a squared plus 5 times 4, 20a minus 25. Oops. Why can't this? Okay. Okay. All right. So graphs of functions. Oh, -5, sorry. Oh my God. I was already moved on to the next problem. Okay.
Wait, should it be plus 25?
Oh my gosh. Oh my gosh, -25. Okay. All right. So let's talk about graphs of functions. We just talked about degrees, right? The degree is the highest exponent. Okay. Whatever the degree is, basically, that's how many times the graph can cross the x-axis. So look, if you have a degree of 0, it doesn't cross the x-axis. If you have a degree of 1, that's a linear function. So for example, if you have y equals 2x plus 5, right? What's the degree here? 1. When you graph this, it crosses the x-axis once. If you have a degree of 2, so for example, y equals x squared plus 3, the degree is 2, it crosses the x-axis 2 times. If you have a degree of 3, it crosses the x-axis 3 times. That's all you have to know about these. Hang on. Okay? If you have a degree of 4, it can cross the x-axis up to 4 times. If you have a degree of 5, it can cross the x-axis up to 5 times. Now, it's possible you have a degree of 3 that only crosses the x-axis once. That's okay, but the maximum number of times is 3. Yeah.
Does it just stop at 5? Or does it just
No, it
keep
goes
on
forever.
going? So it's just, okay.
Yeah, you can have a degree of 100.
And it can, okay.
It can cross 100 times.
Gotcha.
Okay, is this the same thing as zeros, but this is like off with this,
Yeah.
so we get this.
Right. Yeah. Stick with me and I'll clarify some things, okay? All right. So let's talk about end behavior of a function. End behavior is what happens towards the end of the life of a function. All right? So usually when we graph things, we're only looking like here, x equals 1, x equals 2. The farthest out we'll go is like x equals 10, and we're like, oh my God, that's so far away. Now we're going to go far. We're going to go to x equals 1,000,000, x equals 1,000,000,000, x equals 1,000,000,000,000, x equals infinity, like all the way out, into the stars, okay? What happens to the function there? So take a look at this. When you have a graph, if you go this way really, 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 really far, we say that's where x approaches positive infinity. If you go this way, we say that's where x approaches negative infinity. Okay, infinitely far into the negatives. Same with the y's. Here, positive infinity. Here, negative infinity. So, take a look. This is an x squared function, okay? But look at this parabola. As I go further and further and further out, this parabola is going to keep expanding this way, correct? So vertically, if you trace this with your finger, where is this approaching? All the way up to positive infinity, correct? So we say, as x approaches positive infinity, f of x approaches positive infinity. Okay? F of x is the y, remember? So now let's go to the negative infinities. As x approaches negative infinity, as we go to the negative side of this and I trace my graph, vertically, where is my graph going? Up to positive infinity. Vertically, my graph is going up to positive infinity. Okay? So here's another way to say this. If the graph is going up, it's positive infinity. If the graph is going down, it's negative infinity. Okay? So let's do this one now. Let's do this one. As x approaches positive infinity, as I go over to the right, this way, okay? Trace the graph with your finger. Vertically, is it going up or down? Down. Down is negative infinity, right? So we say f of x is going to negative infinity. Okay, now, as I go to the other side, as x approaches negative infinity, where is the graph going? Up or down? Down to negative infinity. Okay, let's do some examples. Okay, let's do some examples. So let's take a look here. First, it says describe the end behavior. That's all we're going to do right now is describe the end behavior for each of them. Okay, to describe the end behavior, you have to write down the template for it. So whenever you hear or you read describe the end behavior, immediately you do this. As x approaches infinity, f of x approaches. As x approaches negative infinity, f of x approaches. This is your template. Okay? Now the answer is going to come here. Okay? So first you prepare your template. Now we're going to write the answer. Okay, so look. As x approaches infinity, so as x is going into the positive infinities, does that mean I'm going left or right? Right. Good. So as I move further and further to the right, trace the graph with your finger. Where is it going? Up or down? Down. So this will be negative infinity. Okay. As x approaches negative infinity, if I go further and further to the left, trace this. Is the graph moving up or down? Down. So negative infinity. Okay? So let's do I know the question is asking you for more, but let's just do the end behaviors first. So again, we're just going to put the templates in. As x approaches infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? Okay, here. And these are the answers. So again, as x approaches infinity to the right, trace the graph as you go to the right. Okay, like the roller coaster. Is it moving up or down? Down, which means what do I write? Negative infinity. So what am I going to write for the other one? Positive infinity, because it's going up. Okay? All right, next one. Okay, so let's write both of these and then we'll solve them. As x approaches infinity, f of x approaches what? I'm going to do both of them. As x approaches infinity. Okay. So here, what am I going to write for the first one? Okay, let's do this. For the first one here, the top one, who says positive infinity? Who says negative infinity? Good. For the second one, who says positive infinity? Good. Okay, so negative infinity, positive infinity. By the way, when it's positive infinity, you don't have to write the plus. It's assumed that it's positive. If you write it, it's not wrong.
So there's not really any math?
No, there's this much math. It's just looking. Yeah, there's zero math. Okay, so for the next one, what am I going to write for the top one? Negative. And the bottom one? Good. Okay, next. Come on. I'm falling into this trap of colors now. Okay, so let's go to the next part. Determine whether it represents an odd degree or an even degree. This says, is the exponent, the highest exponent of this, an odd number, 3, 5, 7, or an even number, 2, 4, 6? Guess how you know. If the end behavior is the same, it's even. If it's opposite, it's odd. So take a look here. For both of them, I have negative, negative, right? even. You see the highlighted? They're both negative infinity, negative infinity. If they're the same, it's even degree. That means the degree of that function could be like x to the 2, x to the 4, x to the 6. Okay, this one, they're different, they're opposite, so it's odd degree. Okay? What about this one? Even or odd? Odd. What about the next one? Even. Okay? What's the next part of this question? State the number of real zeros. That means how many x-intercepts. How many times does A cross the x-axis? 2. 2 zeros. 2 real zeros. How about the next one? How many real zeros? 5 real zeros. How about the next one? And this one, 2 real zeros. Okay? So now, what did we just say? If the degree is even, x to the 2, x to the 4, x to the 6, they both end, either both go down or both go up. Okay, like they both end the same place. So take a look at this. It says to describe the end behavior, but we don't have a graph now. Okay? Okay, here's what I want you to do. Here's what I want you to do. You don't have to make your own. What is the degree of this function? 4. This is the leading term, right? Just look at the leading term. Okay, it's even, so both have to be the same, right? Well, because it's 3x to the 4. Exponent of 4 is even.
An exponent of 4 is greater than an exponent of 3.
Yes. Yes. So it's even. That means now we're going like the opposite direction. You see how when it was the same, it was even, but now. So again, we're gonna do as x approaches negative, or as x approaches infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? Okay, so now, because it's even, these two are going to be the same. So how do I know if I'm going to put positive infinity for both or negative infinity for both? So easy. Is this term positive or negative? Positive. So I just put positive infinity. This one. Okay, so now let's do the next one. As x approaches infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? Okay, now look. What's the highest degree here? 3. So look. So because it's odd, they're going to be opposite. So one of these is going to be positive, one of them is going to be negative. Okay. Always write it in this order. Okay, always write it in this order. So now look, is this negative or positive? Negative. That means the first one will be negative and the next one will be positive.
So does that mean you can never get one on the bottom that's negative?
No, that doesn't mean that at all. Because if this was positive, this would be positive, this would be negative.
But the other one was positive.
Right, so
But
it doesn't work. They have to be different. So now, the only trick with this is, when you write this, you always have to write it in this order where x is approaching positive infinity first, then negative infinity. Then this always works like this. Okay? So there's so little math in this, right? Like no computations, but it's a really, really big deal. Okay, so the homework for this is also from the book. Okay?